Hello students, today's agenda is to check homework. We're going to be learning how to graph square roots, cubes, and absolute values. And today's homework is 11.8. So today students will be able to graph square roots, cubes, and absolute values by creating a table of the mother graph and graphing the transformations. Okay, so we're gonna start by filling out a table for a square root. And so what this means, sorry about that, what this means is, let me focus it a little bit more, is that we give values to x, and of course we're going to be choosing values that are going to be convenient for us, and this should be a 16, not a 19. But why did I choose these values? Why were these chosen? Square root means that you're going to find a number that multiplies times itself 2 times, because that's the index in here. When we don't have it, that means that there is a 2 in there. So we need a number that multiplies 2 times by times itself. It's equals to the number inside, which is going to be your x. Now, what is the square root of 16? Well, it's 4. It's a whole number. If we chose other numbers that are not, if you notice it's a 1, a 4, and a 9, and a 16, those are perfect squares, meaning that your answer for y will be a whole number. The square root of 9 is 3. The square root of 4 is 2. Okay, again, it's just like we're putting, replacing, right? We're replacing the square root of x, which is -1, is equals to, oh, that negative right there. Imaginary number. Square root of y is equals to the square root of x, which is 0. Okay, that's 0. Y is equals to the square root of 1, which is 1, because 1 times 1 is 1. And so on. Okay, so square root of 4 is equals to 2, because 2 times 2 is 4. So that's how we fill out our table. And so we're going to be sketching the mother graph. Whoops. It's a little crooked. So we have 4, 5, 6, 7, 8, 9, and so on. Okay, so the first point says -1 imaginary number, and so that number basically cannot be graphed. Okay, because imaginary number doesn't exist on a coordinate plane. Then 0, 0 means my origin. The next point is 1, 1. The next point is 4, 2. So 1, 2, 3, 4. And then 1, 2. The next one is 9, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. And 16 will be way over there. So we're just going to go with this. Now, it says sketch the transformation y equals square root of x plus 1. And we can get complex in here, but we can also recall some information from quarter 3. And if you remember, when we're adding inside of the parentheses or inside of the square root, then it means that it's going to go to the left. Okay, it's the opposite. When it's inside, it's the opposite. So instead of right, because it's positive, it's going to go to the left. So each point in here is going to affect my x coordinate. So instead of being here, it's going to be here. Instead of being at 1, 1, it's going to be at 0, 1. Instead of being at 4, 4, 2, it's going to be at 3, 2. Instead of being at 9, 3, it's going to be at 8, 3. And so that's going to be my transformation. Whoops, look at that. Okay, that's my new graph. Okay, so this is going to be graphed like that. And we could get into detail to how to get there, but if you wish, you can come and talk to me during lunch and I'll show you why that is. Okay, why would you want to be one less for your x? Okay, so that's all you have to do basically. I'm giving you the table for the mother graph, and then you're just going to be doing your transformations for the homework. You're going to graph this mother graph that I'm giving you the table for, and the new graph, which is going to be different in your homework, obviously. Okay, let's do the next one. Okay, now we have cube roots, meaning that I'm going to look for a number that multiplies times itself 3 times is equals to that number right there. And so, what is the cubic root of -8? Meaning what number multiplied times itself 3 times is equals to -8? And some of you might say, oh, it's an imaginary number, too imaginary. But it's not. It's actually, I'm going to put it in here. -8 can be factored into -2 times -2 times -2, because -2 times -2 is +4 times -2 is equals to -8. So this is possible. And so my answer will be -2. Why? Again, because it's asking one number multiplied times itself 3 times is equals to that number in there. And in this case, it will be -2. The next one is the cubic root of -1. Again, -1 times -1 times -1 will be -1, so that will be my answer. For the next one, it will be 0. 1 times 1 times 1 is 1. Again, what number multiplied times itself 3 times equals to 8? Well, 2 times 2 times 2 is equals to 8. So that will be my answer. And finally, 3 times 3 times 3 is equals to 27. Okay? Now, the graph, and let me look at the values. The values for x, I need up to 8 and -8. And for y, I need no more than 3, so. And -2. Okay, so it says -8, -2, -8, -2. So it's about here. -1, -1, -1, -1. 0, 0, 0, 0, 1, 1, 1, 1, 8, 2, 8, 2. And so my graph will look, my mother graph will look something like this. Okay? But now, how would this transformation look? And so I think at this point I want to show you the summary that we saw last quarter. And you can just write it down again. I'm gonna zoom out so that you can have everything. And so whenever you're adding or subtracting outside of the parentheses or outside of the square root, then you're going up for positive, you're going down for negative. But whenever it's inside of the parentheses or inside of the square root, you're going left if it's plus. So the opposite, right? And that's only if it's inside. And you're going to the right if it's inside but negative. Okay? So it's kind of like if it's negative, we think that it might go left, but no, it's to the right. So outside, up or down. Inside, left or right, but with the opposite direction of what the sign. Okay? So these are inside and these are outside. Something else that you will need to remember, and those are going to be kind of tricky and you're going to start pulling your hair maybe if you don't recall them, but whenever we have a negative outside, or even for the, like if we have the square root, negative outside, then your reflection, your line of symmetry is going to be on the x axis. But if the negative is inside of the parentheses or inside of the square root, okay, so inside, outside. So outside, your x is your mirror, so basically it goes down. Inside, your y axis is your mirror, your y axis. Okay, your y axis is your mirror. So I was telling today to everyone in class, if the negative is inside, remember that you have inside of the house, you have a mirror. It's usually against the wall, so it's vertical, right? And so your image goes on the other side. If you reflect yourself, it goes on the mirror. But if you're outside, like in the woods or outside in nature, think of this as the lake. And so your reflection, if you're over here, you're going to reflect like this, right? So your reflection goes down below. So outside in nature, your reflection goes down. Inside of the house, your reflection goes to the other side. Okay? So maybe that'll help, I'm not sure. But this is just kind of like just to remind you of what you learned in quarter 3. Okay, so in this we have several things going on. We have -1 outside, meaning that it's gonna go down. But also we have a negative outside, meaning that you're outside in nature, and so your reflection is the lake, right? And so let's see. There are 2 different ways that you can do this. You can either do the reflection first, or you can do the going down first. It's up to you. I think I'll do the reflection first. And so this, if it's outside, meaning that the lake is the reflection, so I'm gonna go, my reflection would be here, and my reflection would be here. And for this point, my reflection will be here, and this one would go up. And I'm not gonna make it really strong because that's just one transformation, and this one has 2 different ones. I already did the reflection. Now I have to move that reflection down one space. So this is gonna go down here. This point is gonna go down here. This point is gonna go down here. I'm moving only one space. This is gonna move down here, and the 2, if it's a 2, it's gonna now move to 1. And now I'm ready to graph the transformation, but this one has 2 different ones, okay? And so that will be my new graph, this graph right here, okay? This is just a reflection, meaning that you wouldn't have that, this dotted line. And with the reflection and going down, that will be the blue one. Oh, and I guess I didn't focus back into it. I should have done that before. Again, the reflection first. I just reflect the points on X, oops, from here to here, and then I bring down that reflection 1 point for each one of those points, okay? Okay, what about this one right here? Cube just means multiply that number times itself 3 times, right? So y equals x cubed, meaning -2 cubed. It means -2 times -2 times -2. That will be -8. -1 cubed, that's equals to -1. And it just happens that 2 become positive, but then that positive times negative becomes negative. 0 is just 0 times 0 times 0, so 0. 1 times 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. And then 3 times 3 times 3, that's 27. So I'm going a little faster because I think you're getting the hang of it. And I noticed that for my y, I need bigger numbers, so I think I'm just gonna invade a little bit the next one. So 1, 2, 3, 4, 5, 6, 7, 8. I'm just gonna go up to 9. 1, 2, 3, and I don't need more than 3. And again on this direction, 1, 2, 3, 4, 5, 6, 7, 8. Oops. Okay, so -2, -8, -2, -8, -1, -1, 0, 0, 1, 1, so 1, 1. Remember, it's always move on X first and then Y. 2, 8, 2 on X, 8 on Y. And I don't think I can do 27. I'll go off the page. So that's my mother graph. Now let's see what's the new transformation that we need to do. And so we have a -2 outside. That means that it's gonna go down 2 spaces, and the +1 meaning to the left. Remember that when it's inside, it's opposite of left or right. Inside, left or right, but the opposite. Outside, it means down or up, following the direction. And so this is simple because you don't have to worry about reflection. But in here, every point is gonna move down 2 and then 1 to the left. So it's gonna be 1, 2, 1 to the left. 1, 2, 1 to the left. And this one, 1, 2, and 1 to the left. This one, 1, 2, and 1 to the left. And 1, 2, and 1 to the left. So this is my actual middle of the, no, never mind. 1, 2, and 1. This is my middle. This is this point, and this is just this one. So I'm gonna now, from there, graph it like this, and from here we go like this, okay? And so that's how it would look. Again, 1, 2, and that's the center. For this one, 1, 2, and 1. 1, 2, 1. 1, 2, going 2 down, and oops, 1, 2, and 1 to the left, and 1, 2, and 1 to the left. Okay. And let me check to see if I have an extra one of this one, because, well, I guess I could do the graph down here. Hopefully that won't get you confused. Maybe I can even erase it. I don't know. We'll see. Okay, so absolute value just means that anything inside of that absolute value bars are going to become positive. That number becomes positive. If it's negative, it will become positive. If it's positive, it will become positive. So y is equals to the absolute value of negative 3, which is equals to positive 3. Y is equals to the absolute value of negative 2, it's equals to positive 2. Positive 1. 0. 0 is just neutral. It's not positive and it's not negative. This one, people get tricked and they say, oh, it's negative 1. But no, the absolute value means the distance, and distance is just always positive. So positive 1, positive 2, positive 3. Okay, it's just the positive of the number inside. It's positive 2. The positive of the 3 is 3. Okay, so my mother graph will look something like this. Again, just discard this, don't pay attention to it. And so we start negative 3, positive 3. So negative 3, positive 3. That's my first point. Negative 2, positive 2. Negative 1, positive 1. 0, 0. 1, 1. 2, 2. And then 3, 3. If you notice, we have seen these graphs, right? Like, why do we have a graph like this? Now you know. The absolute value, it just means the positive, not the opposite, but the positive of that value. So that's my mother graph. And in here we have 3 transformations. We have the mirror, it's outside, so it means that it's the lake, meaning that your reflection will be down below. We have the -1, which is it's gonna make it go to the right one, but also this one that I did not summarize it, but it's any time that you multiply by a number bigger than a fraction is a stretch. So it's double as much, okay? And I think I want to do the stretch first, so that we don't get confused, because that's going to be the part that is going to be confusing. When I multiply by 2, it just means double. So instead of being a 1, it's going to be a 2. Instead of being a 2, it's going to be a 4. Instead of being a 3, it's going to be a 6. So my new graph will go something like this, and I'm not pressing hard because later on, instead of being a a 2, it's going to be a 4, 3, at 6. Okay, so that's not my real one. Okay, I'm still just doing the stretch, just the 2 right here. I multiply by 2, meaning I double it for y. And stretch, then it says mirror it. Okay, make your x the mirror. So now I'm gonna go like this, right? Like this, and then like this, twice as much. So instead of -1, it's gonna be -2, -4, -6. So I already did the stretch to make it skinnier, or actually taller. The mirror, send it to the bottom. And the last one is that it's going to send it to the right one. So it's going to be this mirror stretched going to the right one space. So meaning that this is going to go here, 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 one, whoops, so run down here, sorry. And this one, sorry, this one is going to go here, this on 2 is going to go to 3, and this on 3 is going to go on 4. Okay, so this is going to be my new graph. Maybe I'll zoom out a little bit, oops, the other direction. Okay, and that's how my new graph will look. Okay, so again, first thing I did, stretch it, meaning multiply by 2, meaning it's double. So it's a 1, a 2. The 2 is a 4. The 3 is a 6. Same for this side. That's my stretch, times 2. Mirror, I send each of these points down here. The 6 and negative 6. The 2 and negative 2. The 4 goes to negative 4. And the 6 goes to negative 6. I don't mark it well. That was still a dotted line because I still need to do the third transformation, which is, since it's inside, it moves the opposite, so it's positive 1. So I move every point, all of these points, I move it one space to the right. Each one of these points. So 1 to the right, 1 to the right, 1 to the right, the 0, 0 to the right, this goes to the right, this goes to the right, and this goes to the right. Okay, and that's where I put after I did all the 3 transformations. Okay, it seems like it's one of the longest videos, but I hope this helps to clear any questions, and now you can work on 11.8.